There's my vertex. Okay, so we have the vertex, so we need 4 more points because we need a total of 5 points. Now to get the other points, we're just going to go back to substituting in values. So I'm going to pick I'm going to pick values to the left. You could pick values to the right. It doesn't matter, but I want to be smart about this. If you recall, the y-intercept here is going to be at -8 on the y-axis. In other words, it's going to be 0, -8. So in my work, we're going to get other points. And I'm going to build a table. So x and y. So when x is 0, y is -8. And again, we just get that from the equation. So there's really actually no calculation required for that. So I'll just go 0, -8. So 1, 2, 3, 4, 5, 6, 7, 8. And I'll pick that point. Now I want to get another point on the left side here, and I kind of need to think logically about this. What point do I want to use? I don't want to use -1 because I know that this graph is opening down, and it makes sense. My vertex is up here, it's at the top, it's a maximum, and in our equation we can see that we have a negative in front of the x squared. So it's opening down, and so the next point is going down. So -1 would take it off our graph, so we need to pick something like 2 or 1. Okay, so we want to pick 2 points either to the left or to the right, and it helps to pick points that are on the same side as the y-intercept. That's why I'm picking points to the left. So I'm going to go ahead and choose 1 because that'll be an easier number to work with. So let's see, -x plus 6x. So I'll substitute in 1. So y equals, and negative, and then 1 squared plus 6 times 1 minus 8. So this is simply -1, because we square the 1 first and then we apply the negative. Remember, put parentheses around the numbers that you're substituting in. That'll help eliminate sign errors. It's not a guarantee, but it helps. And so, well, that's going to give me 6. So -1 plus 6 is 5, minus 8 is -3. Which makes sense because it's not as low as -8, but it's not as high as 1. It's in between. So on my table, I'm going to put in 1 and -3. So we'll plot that here. 1 and -3. Okay, now that's all the plugging in we'll have to do, because we're going to use the property of the line of symmetry. Again, it's a very useful thing to help us, graph, and we're going to use a property that, it cuts the parabola in half. It's symmetrical. So since I'm going to look at this point and I see that, oh, it's, line of symmetry is 2 units to the right of it. So that means the next point, which is symmetric to this point, is going to be 2 units in this direction. So I would plot that point, which looks to be about, what, 5, -3. And then we do it for the other point as well. So I can see that, oh, hey, this is 3 units in this direction, so I go 3 units in this direction. So that's going to be 3 units there. So I'd plot that point, and we have the required 5 points that we need. So I'm going to go ahead and connect those and get my parabola. So here, this is lousy. Like I said, it's really hard to do it on this wireless pad. Much easier to do it on paper. Okay, so anyway, that's more or less the parabola that we are looking at. Or this is the parabola that this graph equation will produce. Okay, so let's look at one more thing. Let's say we want to find the minimum or maximum value of y equals negative 2x squared plus 4x plus 3. But we want to do it without having to graph it by hand. So there are a couple of ways of doing it. One way would be to find the axis of symmetry and then find the y value. You know, just like we did with the last equation, that would give us the vertex, and then we can see, because this is a negative equation, or the a is negative rather, it's going to be a maximum. So it's going to be opening. It's going to be opening downward. We could do it that way, or if we have a calculator available to us, and we do, we can use that. So here's how you can do this on a calculator. So the first thing I'm going to do is graph the equation. So negative 2x, and what was it? Plus 4x plus 3. So plus 4x plus 3. Okay, so now we will graph it. Oh, my mistake. I forgot to put the squared. So I'm going to go second, insert, squared. Now, that's why we're getting a line. Okay, so now I have my parabola. Okay, so I clearly see it's opening down just like we anticipated, and the vertex is going to be a maximum. But instead of having to find the axis of symmetry and then plugging in the axis of symmetry, the x value, into the equation, then finding the y value to get the vertex, let's go ahead and do this. We're going to press second, and I hope you're getting this down, and then calc. And here we're given a list of values, or a list of options, and what we're trying to do is we're finding a maximum. So I'm going to select option 4. Now, your calculator is going to ask you, left bound. It's asking, where should I look for this maximum? Set the boundaries, because it's not going to necessarily look at the whole graph. So you got to tell it where to look. So left boundary means I want, it's not going to go any further to the left than where I tell it to. So I can use the left and right arrow keys to move this cursor along the the graph, and I want to move it just a little bit to the left of the vertex, and then I'm going to press enter, and a little arrow pops up. It's hard to see, but a little arrow pops up denoting that, and then it's going to ask for the right boundary. Okay, so I'm going to arrow to the right, just a little bit to the right of the vertex, and I'm going to press enter. And as you can see, there's a little arrow that pops up here, and it's going to look So these are the boundaries. So it's going to look for the highest or the highest y value, the maximum between these two arrows. And that would be, hopefully your vertex would be in there. So then I'm going to press enter. And then we can see right at the bottom, it says the maximum is x is equal to 1 and y is equal to 5. So therefore, in our answer, we're going to say, oh, it's a maximum of y equals 5. Okay, so that's how you can use a calculator to find minimum or maximum. Anyway, that concludes graphing and using standard form of a quadratic. Next time we will hit two different forms. See you then.